Here's the video for section 2.5, and this is going to be about a few more applications of solving right triangles. First of all, we need to talk about using bearings. There are two methods for doing this. In the first method, we're just given a single angle, such as 164 degrees. The way we figure the bearing in this case is that we start from due north and go around clockwise. Here are some examples of using method 1 for bearings. If we have a bearing of 32 degrees, that means we're going to start from due north and we're going to go clockwise 32 degrees. So that gets us to right here. The direction we'd be going would be this direction. If we have 164 degrees, again we're starting from due north and we're going around 164 degrees clockwise. That puts us somewhere between south and southeast. And last of all, if we have a bearing of 304 degrees, we're starting from due north, going around clockwise 304 degrees. That puts us a little bit past 270 degrees, which would be over here. We'd be going off in this direction. Here's an example where we're actually using the bearing to solve a problem. So in this one, we've got our two radar stations, A and B. It's a little bit confusing because it says they're on an east-west line. And to me, that would mean that A was east of B, but that's not actually how they meant it in this problem. Here's what the picture actually is. The A is meant to be to the west and the B is to the east. But they're 3.7 kilometers apart. And this radar station detects a plane at point C on a bearing of 61 degrees. Going 61 degrees clockwise, this is the direction that the plane is in. From station B, the bearing to the plane is 331 degrees. So down here, I'm starting from due north, going around 331 degrees. The idea is where these two intersect is where the plane would actually be. And what we're asked to find in this problem is the distance from A to C, so the distance from here to here. Right now, we don't really have any of these angles. We do have one side of this triangle, but we're trying to find this distance right here. To do that, we're going to have to figure out what some of these angles in the triangle are. Now we know that this is an east-west line, and this is due north. That means that this right here is a right angle. And we've got part of it already, 61 degrees. So this angle here would be the complementary angle to 61 degrees, and that would make it 29 degrees. 29 plus 61 adds up to 90. We can do the same with this angle over here. We know all the way around from here to here is 331 degrees. We also have a right angle right here. So there are a couple different ways we could do this. We could say that going from north all the way around to west would be 270 degrees, and we could subtract that from the 331 degrees, or we could see what angle would complete the circle, and then that angle would be complementary to this one. I just chose to do the 331 degrees minus the 270 degrees, which gives me 61 degrees. So that gives me this angle right here. Now I also want to see what angle C is, and we know we've got three angles in a triangle that have to add up to 180. We add these two together, guess what? We get 90 degrees. That means that this angle up here is also 90 degrees. Now we've got the three angles and we've got one side, so we should be able to use a trig relationship to find this other side that we're actually looking for. Now since this picture is kind of messy, I'm going to redraw it over here. So here's my redrawn triangle. What I'm trying to find is the length from A to C. So I could just leave this as AC, or I could call it something else like X. Let's look at the 29 degree angle and see what these other two sides would give us for a trig relationship. So for the 29 degree angle, this side is actually the hypotenuse. That's a little bit harder to see in this picture, but remember this is the right angle over here. The hypotenuse is always across from the right angle. So this is the hypotenuse, and then this side over here is actually the adjacent side. My relationship that involves the adjacent and the hypotenuse is cosine. That tells me that the cosine of 29 degrees would be adjacent over hypotenuse, which would be x over 3.7. I just want to solve this for x, so I could multiply both sides by the 3.7. The 3.7 would cancel out on this side, and that would give me x. When I multiply this with my calculator, I get 3.236 approximately. Now I want to look at how many significant digits I have. I've got 2 in this value and 2 in this value. So I need to round this to 2 significant digits. That would make it rounded to the nearest tenth. So that's going to be the answer to my question for the distance from A to C. I want to put in the units. This distance was measured in kilometers, so that means this is going to be kilometers. So this would be 3.2 kilometers from point A to point C. Now we'll look at the other method for bearings. For this method, we start with either a north or south direction, and then we have an acute angle to show the direction either east or west from that line. If we have north 42 degrees east, that means we're starting at due north and we're going 42 degrees to the east. And that's why I labeled each of these with north, east, south, and west. So this would start north and it would go 42 degrees towards the east. So this would be our bearing right here, and that means we're going off in this direction. If we have south 40 degrees west, then we're starting at due south and we're going 40 degrees towards the west, which would be this direction. So here's our bearing right here. And this one, if we have north 52 degrees west, we're starting at due north and we're going 52 degrees this direction since we want to go towards the west. Now for each of these, we could also write them as bearing with method 1. This one would be the same as with method 1 because we're starting from due north and going clockwise. So this would also be 42 degrees with the other method. For this one, to do the other method, we'd start from due north and go all the way around to here. So that would give us 180 degrees to here plus another 40 degrees, which would be 220 degrees. For this one, to use method 1, we'd start from due north, go clockwise all the way around to here. To figure this out, we could go all the way around 360 degrees and then back up 52 degrees. So this would be 360 minus 52, which would give us 308 degrees. So this one would be the same as 308 degrees using method 1. In this one, we've got a ship leaving port, and it sails first for a while at one bearing, and then it turns and sails at a different bearing. So here's the beginning of my picture. I've got the port here. From there, the ship is sailing at a bearing of north 47 degrees east. So here's my due north and my due east. So I'm starting from here and going 47 degrees to the east. Now I don't know how far it's going in this direction, so I need to figure that out. It does give me the speed of the ship, and it tells me how long it sailed at that bearing. I'm going to use this formula to figure out the distance that it went in this direction. That's distance equals rate times time. So I've got my rate is 22 knots and my time is 3.5 hours, and that's going to give me 77. And since this was in knots, which is nautical miles per hour, technically this is going to be nautical miles. So now we know the distance that we want to make this line segment. Then at that point, the ship turned and sailed on a bearing of south 43 degrees east. So I'm at this point where it turns. So from there, I want to figure the new bearing. I want to draw my due south direction, and it's going 43 degrees to the east from there. So that means that this angle right here is going to be 43 degrees. Again, I want to know how far it went in this direction. I'm going to take my 22 knots times the time of 4 hours. So this time I have 22 times 4, which gives me 88 nautical miles. So this distance right here, I want to make it 88. Now I want to draw in a line that goes from the port to where the ship is now. This distance down here is actually the distance I'm interested in. Let's call this one D. So that's all the way from here to here. It's not the horizontal, but it's this line that's going a little bit below the horizontal. I'm going to redraw this triangle to make it a little bit easier, but before that I can figure out some more angles in some of these triangles. From north to east is a right angle. So this right here is a right angle, and that means that this angle right here would have to be the complement to this one. That would make that one 43 degrees. Over here I can figure out this angle also, because right here I've got from south to east. That would give me a right angle right there. And that means these two angles are complements, which would make this one 47 degrees. Now that doesn't really get me the angles in the bigger triangle that I'm looking for, but it does let me find out one thing, and that's what this angle is up here, this entire angle. So far in this triangle, I've got 43 degrees and 47 degrees. Those two add up to 90 degrees. If I subtract that from 180, I get 90 degrees, and that tells me this angle is a right angle. So I'm going to redraw my triangle so that I don't have this extra stuff in it. Here's my redrawn triangle. All I know is that this is a right triangle, and I've got two of the sides, and I'm trying to find this third side. Since I don't have the other two angles, the easiest thing to do here is just use the Pythagorean theorem. And it happens in this triangle that the length I'm looking for is the hypotenuse, because it's across from the right angle. I would take 77 squared plus 88 squared, and that's going to equal d squared. If I do this on my calculator for this side, I get 13,673. Then I'm going to take the square root of that to get my answer for d. This gives me 116.93, and there's some more digits there. Now I'm going to go back and look at how many significant digits I have. All of the numbers that I have in here are 2 significant digits. So I'm going to round this to 2 significant digits, which means I'm rounding it to the tens place. That would give me 120 for my answer. So the ship is 120 miles or nautical miles from port. One last problem. This is kind of a tough one, so we have to set it up really carefully. Francisco's trying to find the height of a tree. He stands at one point on the ground and he finds out that the angle of elevation to the top of the tree from there is 36.7 degrees. Now here's my picture. So here's the tree. Here's his first location where he was standing. We don't know how far that was because the problem didn't tell us, but it does tell us that the angle of elevation from there to the top of the tree is 36.7 degrees. And since he's trying to find the height of the tree, I decided to make that h. So here's my h in my picture. And I wanted to set a variable for this distance since I don't know that. So that's d1 is the distance from his first location to the base of the tree. Then what happens is he moves back 50 feet. So this is his second location. And from that point, the angle of elevation to the top of the tree is 22.2 degrees. So we've got a different angle here. Now what we want to do with this is find the height of the tree. This is a little bit misleading because you might think that you can just use the h and the d1 or the h and the 50, but actually you can't do that. 50 isn't the base of this bigger triangle. The base of the bigger triangle would be d1 plus 50. So for our second triangle that we're looking at, that side is actually d1 plus 50. Let's start with this smaller triangle and just write a trig relationship between the angle and the h and the d1. For this angle, the h would be the opposite, the d1 would be the adjacent. That would give us tangent. That tells us that tangent of 36.7 degrees is h over d1. That's all we can do with that triangle for right now. Now let's look at the bigger triangle, which is this entire thing. We can do the same trig relationship for that one. This time we would have tangent of 22.2 degrees. And our opposite side is still h. Our adjacent side is this entire base of the triangle, which is the d1 plus 50. The question is, how do we put these two together so that we can solve it for h? Because that's our end goal, is to find the height of the tree. We do have two variables because we don't know the h or the d1, and we've got two equations, so we should be able to put these two together to solve it. And a lot of times if you're trying to solve two equations with two variables, you can use the substitution method. To do that, you have to have one of the equations solved for one of the two variables. Let's take this first equation, since it's a little bit simpler, and let's solve it for the d1. To solve this for d1, we could cross multiply That would give us d1 times a tangent of 36.7 degrees equals h. If we're trying to solve it for d1, that means we'd want to divide both sides by the tangent of 36.7. We've got that. Now the idea is that we can substitute this expression into our second equation in place of the d1. That will give us an equation that only has h in it, and then we'll be able to solve that for h. So now we're going to take this equation where we have the d1, we're going to substitute in this expression. And I want to be really careful in doing this substitution, so I'm going to put that expression in parentheses. Now I've got kind of a nasty equation here. I'm going to start out just by simplifying it as easily as I can. And first of all I'm going to do is cross multiply. The tangent of 22.2 degrees times all of this that's on the bottom on one side. On the other side I just have 1 times h. Then I'm going to simplify on this side a little bit by distributing this tangent of 22.2 degrees. Next, I want to get all my h terms on the same side. I'm going to take this entire term and move it to the other side by subtracting. Now this is getting really messy, so I'm going to go ahead and put this into my calculator and get a decimal approximation for it. There's my decimal approximation. Notice I took it out to 6 decimal places just to make sure I had enough. Now I can combine these two terms. Remember that there's actually a 1 in front of this h, so I can just subtract those two values. That gives me h times this value. Now all I have to do to solve this is divide both sides by this value. On this side I'm going to put all of this in my calculator in one step, and that'll give me the answer for h. When I do that, I get 45.092888 for h. Then I want to look at how many significant digits I have. I had 3 significant digits here, 3 here, and actually this one was 2. Even though there's a 0 here, there's nothing that said we were rounding to the nearest 10 feet. We can assume this was rounding to the nearest foot. That means 2 significant digits, which would mean rounding this to the ones place, which would be 45. So the answer to my question for the height of the tree would be 45, and these units were all in feet, so this would be 45 feet.